I don't get it, because you guys, when we use Blackboard, is it about recording or about Blackboard? It's just that I'd like to see which platform works best for those that can connect.
It's about logging in. There's no network.
Yeah, but I'm saying that that's I also didn't have electricity. But what I'm saying is I can record on this. So I've started recording now. The issue is that my understanding was that people couldn't access Blackboard as easily. Because the last time when we did Google Meet, we had a large number of people attend. So I'm just trying out all these things, and then you can tell me. I don't have a problem doing, a Blackboard, but then you guys seem to be the ones who have other preferences. Can you hear from you? Because Blackboard is an official portal, but it doesn't always work as well as it should. Can I hear other views? Chiviri. Huh? Chiviri, can you hear me? Iman. Iman. Hello. Arafat. Iman. Iman can't hear me. Kumalo. Melo Kuche. Can you hear me? Bali. Is that Bali?
Yes, sir, I can hear you.
Yeah. What's your preference?
Everything works fine with me. I've never had connection problems with any of the platforms.
Oh, okay. Well, with this one, we can record. It's pretty straightforward. I'm not sure. Yes, Arafat, I'm saying to you, which platform do you prefer? You see, what I like about this platform, it's even better than, I think it's even better. Because then I can see people chatting at the same time. But anyway, okay, I have started to record, so that's fine. I will then post that recording. Just need to think, because the recording can be quite big. So we'll see how I can post it on Blackboard, or I can email it to the class rep. Okay, guys, so what we're going to do is we are going to do a little bit of, oh yeah, the other thing is that I need ideas from you guys about how you're going to write your tests, right? So if you know a good site that we can use, otherwise I'm going to try and think about a site or app, because you know that we need to write a test next week, right? Already. We have 5 weeks of this, and the 5 weeks is coming up. So the 5 weeks includes the module 1.3, and then we're going to go back to module 1.2 and quickly do some stuff there. Okay, yeah. So this, it's getting serious. Right. I just wanted to do you have any questions? So if you have any questions, you know, you can put them on the chat, or you can speak up. But I wanted, so sometimes, you know, when I get these things, I look through them, and then I will say to you, you need to redo it. You know, so if I pick up mistakes, you can't then come back to me and say, oh, do I need to redo it? Of course, you need to redo it. Otherwise, I'll mark you down. I'll give you whatever mark you deserve. Okay, so don't be lazy about redoing stuff, because you learn then. Okay, I just wanted, I'm going to use Arafat's I'm trying to also admit other people here. Yeah, so I'm going to use Arafat's assignment and then I'll look at other things. When I got this assignment from Arafat, I said to him that he should redo it. Okay? There were two things. In fact, I think this is the second time he's redoing it. So you guys need to be very comfortable with drawing structures, right? You need to be very comfortable. So I like the fact that Arafat is now a bit more comfortable with drawing structures. You know, the rings look as like rings, and these structures look like real structures. What I'm going to try and do is I'm going to mute all of you guys so that you only unmute. Okay, so yeah, so that you will only unmute if you need to ask a question, otherwise put it in the chat box. Okay, so yeah, so I'm glad that Arafat is now, and a lot of you guys are now drawing these structures. Nice. That is very good. So I looked at this and then I said, Arafat, you need to redo number 1. You need to redo number 2. That's what I said to Arafat. I think the others are fine. So I would like you guys to tell me why, and Arafat maybe, why, look at number 1 and tell me what's wrong with number 1, because it's got one of the most common errors that we generally have with esters. Okay, so can you look at number 1, tell me what's wrong with number 1, and then also tell me what's wrong with number 2, because those two are not correct. Okay, you can put it in the chat box, or you can draw. By the way, we also use WhatsApp, so if you want, you can even be using WhatsApp. Okay, Arafat says you need to download. Not really. You can also join on the web, by the way, because there are 2 ways of joining Zoom. So you can just join on the web, or you can join using a downloaded app. Okay, so you can put answers here also on the WhatsApp group if you like, if it's too much, because sometimes I just want you to draw stuff, right? Yeah. Okay, so let's do that quickly before we get into the well, okay, you're asking about you have to be accepted. Right, this is KP. So put in browser window, and then it should prompt. Okay, so we got 27 people. Okay, so guys, or does anyone want to explain what they see there that is not correct? Komolemo, can you explain to me why this thing is not correct? Iman, then I'll come to Innocentia. So you guys better get ready with your answers. Okay, why is this not correct? You say I added an extra carbon on my ester. Which extra carbon now? I don't think you did. It's a very common mistake. Okay. Homolemo, can you unmute and tell me where the problem is? Iman, can you also unmute? And then Bali, can you unmute and explain to me what your issues are?
So we're on number 1.
Yes, for number 1.
Okay,
You're saying acetic acid should have 2 carbons.
yes. Oh, yeah.
But where's the acetic acid here? This is ethanoic acid, acetate. So what 2 carbons are you talking about? Okay, so he's got 1, 2, 3. So actually, yeah, okay, that's a good observation. So in this case, the ethanoic acid is not correct because you've put what? Propanoic
3
acid.
carbons.
Okay, that's a good observation that I had missed out on. What else is happening there?
What else is happening is the product.
What about the product?
It should be 2 carbons that are holding the carbonyl group and the other O. Only 2 carbons that are holding the carbonyl group.
Yeah. Okay, but that's okay. So what's the issue here?
The issue is, isn't it we use the name that takes the parent name is the name of the alcohol.
Okay.
Yes, so we start by taking the carboxylic acid and then we join it with the alcohol, but we remove the OH.
Okay.
So when we join them, we're gonna start off by drawing the carboxylic acid.
Okay.
And then we're going to remove the OH from the 1, 2, 3, 4, 5, from the pentanol.
Mm-hmm. Okay.
And then we join them, and then the byproduct is water.
Yeah, that's fine. So what you see here, what you have done here is that you've actually told us that 1, 2, 3, 4, 5, 6. So you've actually got pentanoic acid. You see that? And then you've got 1, 2, ethanol. This would be ethanol.
Mm-hmm.
Do you understand that, Arafat? You can't hear anything. Sometimes if you can't hear, so you might have to log off. Okay, so do you guys see the issue here? Right? So then it's a different compound and it's got starting material. So in fact, this compound that you drew here, Arafat, is actually what? It's ethyl pentanoate. Do you see that? Yeah? Ethyl pentanoate. That's what you drew. Right? So, okay.
So don't I draw ethyl hexanoate over there? Because there's 6 carbons attached, well, on the chain that attaches to the double bond O.
Here.
No, by the ester.
Yeah.
There's
Here.
6 carbons. Yeah.
Yeah, but
So
then,
I think,
so this is 1, 2, 3, 4, 5, 6. Okay, sorry, yeah, it's hexanoate rather. Hexanoate, because what you've done here is you've got this carbonyl is what belongs to the acid, right? So what you've actually got is 1, 2, ethyl hexanoate, right? And not what we wanted, which is pentyl. So this would be pentyl acetate. That's what we wanted. You understand that?
so when they ask for the common names, or when they ask for the name of a compound, should we give the common name or the IUPAC name, or will they specify?
Normally I specify, just like in the last assignment, I said I need IUPAC name. You know, yeah, this is, so yeah. But the important thing here is not so much the name, it's the fact that, so let's go on to number 2 here. So you tell me what went wrong here. You see, what went wrong is this bit again, because now you have a long chain acid, and here you don't have a long chain acid, you have an alcohol here. You see that? So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So in fact, this one would be nonate. Nonate. I just can't write with this. Yeah, nonate, because it's 9, right? So if we say nonate, and then the short out, so the alcohol now is 1, 2. So it's ethyl nonate. It's not octyl ethanoate, because with octyl ethanoate, the this carbonyl should actually be on the ethanoic acid part. Do you understand that? So this is a very common mistake that people make.
So I also used propanoic acid instead of ethanoic acid there.
Where is that? Yeah. That's why I told you to repeat that or to revise that. Okay, when we look at this one, so you see this is your carbonyl here. So all you need to do is just take out the H, right? And then you just plug in the carbon chain. So so this you would also take out, the OH you take out, and then all you do is you just plug in the carbon chain, which is a 2 carbon chain, onto the carbonyl group. Okay, so that's how we do it. Right. Let me just, there's an issue here with electricity. There's a battery is running low. Okay, we are back. So you get that. So I just wanted to point that out to you guys, to say that you have to be careful. Okay. Right. So what we're going to do now is we're going to continue with amines and amides as we did last time. The other thing is you guys need to challenge yourselves, because when I give you an assignment, you just generally you play very safe. Like I said, oh, you know, tell me about amines, and all you do is you just kind of reproduce the stuff that I had given you, you know, very small chain type of amines. You need to get adventurous and show more amines. Okay, so we talked about the IUPAC. This is the IUPAC system, where you then have like propanamine. Okay. And remember, we said that these things are really based on ammonia. Can I ask a question here? Right? Why is the alcohol, why does it have the highest boiling point of the series? Okay, you can put that answer in the chat box for me, please. Because I want to know if you understand what's going on there. So of any of these, the series here, and one of the questions I can ask you is maybe to work out the molecular mass, you know, and then to name these things. So you should be able to name them. What's secondary, what's tertiary? And then I always like to ask that question. Why does alcohol have the highest boiling point? Okay. So in the chat box, can we get all the answers, please? Yeah, but that can't be the answer. You know, you need to be patient, and you need to explain properly. So in other words, you need to say, you know, you need to talk about the whole series. So you can't just talk about, okay, so alcohols. All right, you need to frame it in a proper way. Can you do that? Why in the series does alcohol? And what about the others then? Why don't they have D? So that's why I'm saying you need to be able to frame the argument there. It's not just, okay, alcohol is strong intermolecular forces due to having hydrogen bonding. And what about the others in that series? What is it that makes them not have? And strong intermolecular forces, what strong intermolecular forces are those? Due to having hydrogen bonding. Okay, I suppose it's hydrogen. Can I get responses from the rest of the guys in the room? No responses, but we talked about it last week. And what we said is because of the polar bond there, I think it's actually here, you know, because of the polar bonds, the O and the H create, you know, more, they are more polarized as a bond than the N and the H. Therefore, there is a stronger attraction, which we would call hydrogen bonding. There's hydrogen bonding, which is a stronger intermolecular bond, right? So then it takes more energy for you to break that intermolecular bond, which is a hydrogen. Whereas when you look at the amines, they don't have strong hydrogen bonding as strong as alcohols. And then when we look at hydrocarbons, there are no polar bonds here. So you get either van der Waals forces or even London forces, London bonds, which are very weak. And therefore, it takes very little energy for you to separate the molecules. So you need very little energy to break the intermolecular bonding within hydrocarbons in general. And then I think we talked about how in primary amines, just like in primary alcohols, those bonds are also stronger. It's really more structural or steric than in a secondary and tertiary. So you need to be able to understand that. And that was the question. That question will definitely come. No two ways about it. Okay, so some important amines. So amines are more stable when they're salts, right? But it also allows these salts to be in solution, so to solubilize. And remember that in the body, only soluble or solubilized molecules are absorbed, right? And that is why amines and their salts make such important drugs. Okay, so you will see here that we have ephedrine, which you get now that it's winter. Everybody is buying ephedrine type products for sinus, as decongestant. So this, you get it in Sudafed, right? And in a lot of these cold remedies. Okay. You can see that it's also an alcohol. You know, it also has an alcoholic component to it. Okay. And then over here, you can see that it becomes charged just because it has more bonds around it than it should. Okay, normally it should have 3, but now it's got something else there. And then this, so it becomes an organic salt. So organic salts are very important, right? Diphenhydramine, and you can hear from the name, right? Like we said, ephedrine. So it tells you something amine, right? Diphenhydramine. Why is it di? Because it's got 2 phenyl groups there. Okay, diphenhydramine. Okay, the amine is over here. Okay, again, we use this in cough mixtures, right? There's a famous cough mixture, benylin. Benylin has diphenhydramine in it. Okay, and it's a antihistamine. Okay, and here they are. Okay, you've probably seen Sudafed, and then this product is really an American product. What we have normally in South Africa is benylin. Okay, and these are the IUPAC names, so you can try to see here how it works out. So when you look at this one, they are looking at it as a propanol, right? Because it's 1, 2, 3. So it's a propanol here, and then on this side is the phenyl, right? Group there. And then on this side is methylamino. So here's methyl and the amino here. Okay. Right. 2-methylamino, 1-phenyl, 1-propanol. Okay, the other one is cocaine. Cocaine is in an amine, right? And it's a narcotic agent. And for you guys who've been watching TV, you probably know about the narcos, right? So where does cocaine come from? Mostly South America. It comes from the coca plant, which grows in South America. And that's why you get the narcos, these gangs who deal in narcotic substances, right? So narcotics, where historically, narcosis is really killing pain in a sense, or in the sense of narcolepsy, it's sleepy, being sleepy. So these are things that have side effects that make you sleepy because they get into the brain. Okay, so here you have cocaine and hydrochloride. So it becomes a salt to stabilize it. Okay, and you should by now be able to see what functional groups they are here. Okay, can you just write down in the chat box what functional groups you see? Okay, they are probably 1, 2, 3, 4, maybe 5 functional groups. Can you write those down in the chat box? Because this is exactly how the story goes. I'm going to give you a structure like this, and then the first thing I'll ask you is to a ring. So you have to draw a ring. If I say draw a ring, so you draw a ring around the functional groups, and then you name the functional groups. You don't just list the functional groups. You name them, and then I could ask you for the name, whether it's the common name or the IUPAC name. Yeah, whichever. So can you write in the chat box what functional groups, and write all of them, okay? You can't just be writing one, because it's not you're writing for yourself. Okay. Let me just see what you guys have done there. Yeah. So you see, rapiri, this is the kind of thing I don't want. You can't just say ketone. I'm saying to you that there are 4 or 5 of those things. Okay. And you need to put it on the group, because you need to be learning from each other. Okay. Yeah. So let's do that. Can you put on the chat, in the chat box, what functional groups you see there? And by the way, there's no ketone there. So at this stage, if you're seeing ketone, it's a bit worrisome. Okay, I'm waiting for answers. Sakira Bika, you see, you're not listening. I'm saying to you that you need to write out 4 or 5 functional groups, and you just decide you're going to write one. So I don't know what Yeah, so there is no such thing as a benzene group. I think it's something that we have gone over and over again. Okay, this is a benzyl group, or you could call it phenyl group. Okay. Okay, so you'll have to reflect on your answers there a bit more. But at this stage, I do expect that you know functional groups, because these are easy marks. Okay, so let's get on with it. So you've got a benzyl group here, right? And carbonyl is not really a functional group. Okay, it's just a sub-functional group, because you see you get it here, you get it there. Okay. So actually what you have here is you have an ester group here, right? You also have an ester group here. So, people were correct. Ester group. And then you see you have a methyl group here, right? Because this was probably methanol. So you can now see how we can make this structure if we wanted to. Okay, so you've got an amine group here. You can even tell us, you can see that it's a tertiary amine group. Okay. Halide group. Okay, that's fine. So this is a salt of some sort. Okay, so that's what you've got. And if a possible reaction here, okay, could be this group. Remember where esters come from. They come from acids and alcohols. So we could actually remove this group and we end up with an acid here. Okay. But what these guys have done is they have reacted. So when you react a hydroxide with this thing, what you get is that the hydroxide is going to take out. This becomes an acid, isn't it? HCl comes out, and then you end up with just N-methyl. So this is an N-methyl group, okay? Which then is a cocaine-free base, as we would call it. So this is a difference between cocaine and crack cocaine, and this is much more potent. So you need just a little bit of this, and yeah. Yes, KP, you have a question. Go ahead, ask the question. You can unmute. Or is it in the chat box?
Professor, I wanted to know what happened to the OH. It was the cocaine hydrochloride plus the sodium hydroxide. So the
Okay, what
product,
happens in those things? What do you think is going to happen there? What are you going to get?
I was hoping that the hydroxide will join one of the groups to create something, but I don't see it.
Normally, what does it create?
Carboxylic acid or alcohol.
No. Hydroxide can't do that. Hydroxide will
Okay.
create water. You see that there's an H and there's an OH. How does it create a carboxylic acid when it doesn't have carbon in it? Yeah. And then you have a salt here. The chloride will react with the sodium. So you have, sodium chloride, and then you have water.
Yes.
Yeah.
Okay.
Yeah.
Okay. Thank you.
Yeah.
So.
All right. Cool. Yeah, so that's the story of cocaine. So you need to understand where cocaine comes from. It actually comes from a plant, the coca plant, which grows in South America. And that's important for you to know. Okay. So when an amine has, when you react amine with water here, what you get is a kind of salt, right? And also when you react it with acid, you also get a salt. Okay. It's almost acid-base reactions, remember, because the amine is a base. Remember, it's based on ammonia, which is a very strong base. So these are actually acid-base reactions that you are seeing there. Okay, so it looks different, but it isn't. It's just the same. Okay, we're going to talk a bit about some more complex amines, which I'd hoped you would come up with. And these are called heterocyclic amines because hetero is different, and then cyclic is in a ring, and then amine. Okay, and they are very common in nature. So you get these ones. Okay, they actually, so you get pyrrolidine, pyro, imidazole, indole, purine, quinoline, pyrimidine, and pyridine. Okay. So why are they heterocyclic? It's because they are nitrogens which are in a hydrocarbon, so hydrogen and carbon rings. So that's why we call them heterocyclic. Okay, if you look at something like benzene, it's actually a homocyclic ring in a sense because, well, it only has hydrogen, it's a hydrocarbon ring. Okay, so it's not so important for you guys to know the structure, to know the names of the rings. Okay, you don't have to know that, but you need to appreciate that they're amines. I will not ask you, okay, draw an imidazole ring. Okay, so I won't ask you that unless I've given you enough information. What we might ask is just for you to say, okay, what functional groups are here? And in that case, you can just say, you can see amines. If you're able to say, okay, it's a quinolone or quinoline, then I mean that's fantastic. But what we see here is you have a benzyl group here, right, which is fused with a heterocyclic amine. So it's good enough for you to say that, right? Now you guys are going to be pharmacists, and these rings are probably the most important drugs that you will ever come across, and they're also very old drugs, which, okay, here is just a check. We're not really interested in you naming this, okay, but they get very complex. Okay, so you've got a porphyrin ring. So as you are sitting there yourself, you actually have this complex structure in your body, in your blood, right? That's why amines are extremely important. Okay, so you have what's called heme, which is why we talk about the hemoglobin, right? The red substance of your blood. And it's very good because it's able to actually carry iron in it. Okay, so if, say, you have a shortage of iron, like iron anemia, it might actually have to do with the fact that in some cases that this this porphyrin ring is no longer able to react and capture iron. Okay, and that happens in conditions such as what's called methiminoglobinea. This is when, let's say that you are sitting on Mbaula, like now it's very cold, so you're sitting on an open fire, and maybe you decide it's too cold, so you close up every little nook and cranny in the room, every little space where oxygen is coming through. So what then happens is, that's why people die, right? So what then happens is that there are changes within the porphyrin ring because there's no oxygen anymore, right? And then you have so you have methylated hemoglobin, in other words. And then that methylated hemoglobin is not able to take oxygen because the F here, the Fe is the one in a redox reaction, reduction oxidation reaction, which actually reacts with oxygen. Okay. So yeah, people die, and you will read about it in the newspaper. When it gets very cold, people are in confined places, they die because of that. The other thing is histamine, and histamine is again something that is there in your body, right? It is produced by your body as a reaction to an allergy, right? So let's say that you get stung by a bee, or maybe that you are allergic to pollen, you know. So histamine is the one that gets released, and then you start either tearing, let's say tearing up because your eyes just start watering up, or you sneeze. You know, when you're sneezing, it's because you've got dust or pollen, and then histamine is produced in your body. And you can see it's histamine, right? It's got another name, 5-HT, which is 5-hydroxytryptamine. Okay, so right, but we call it histamine. And what do we do to stop an allergic reaction? We give an antihistamine. Okay, and that antihistamine is something that looks like histamine but is chemically different. Okay, what we will do later on this week is I'm going to send you some scenarios. Now that you have all this knowledge, we'll be able to quickly solve these scenarios. Okay, the other thing that you also have in your body is epinephrine, right? Epinephrine, that's what the Americans call it, but we like to call it adrenaline. Adrenaline. And again, you can hear the way that it's, you know, the end part, amine, and telling you that it is an amine, you know, epinephrine. So here you have adrenaline, and you can see that it's also an alcohol at the same time. It's got alcohol functional groups in there, right? And then it's got alkyl group. There's an alkyl group here. And then N, so this is N-methyl, isn't it? Yeah, okay. Right, so, and these are three things that are in your body. We also have a lot of amines in our bodies because amines are very good as neurotransmitters and as hormones, right? Yeah. And then in plants, we generally have what are called alkaloids. And why are they called alkaloids? Because they are alkaline, you know. So again, when you think about pH, so their pH is above 8, and they are amine containing compounds, and these are produced in plants. And because they can be very similar to what is in human beings, they then find a lot of use as medicines, right? And mostly as medicines that can penetrate into the brain, right? So that's why they are stimulants, okay? Now, maybe let me stop there and then ask you guys, this is what I was kind of expecting from your assignment, to say, because in your assignment, I want you to appreciate the organic compounds around you. So I'm going to ask you again, can you list some compounds around you which are amine in nature? You know, compounds that you come across that have amines in them, if you like. Can you list that in the chat box? Not one, at least 2 or 3. Okay. And that's what I would have wanted. That's what I was expecting you guys from your assignment. So I wasn't very impressed with your assignments because you just tended to regurgitate stuff that we already had done. Okay, right. Chat box. Go to the chat box and please put for me some common amines. At least 2 that you know of. Okay. Okay, so the attendance is pretty good. So we'll have a little thing at the end there to just find out what your experience is like. Amphetamine, tramadol. Yeah, but I want you to, Arafat, I want you to think about where you are right now and just tell me what you know what amines you have access to. Can I hear from the other people? Maybe you have access to cocaine, right? Okay, that's good. So in coffee, you get caffeine. And what else? And you can hear from that caffeine. Okay, what else? Tell me something else. Okay, so we've only got one answer. I mean, it's, you see, yeah, what's in cigarettes? Can you tell me? Okay, nicotine, right? In cigarettes. Okay. Fruits and veggies that are high in protein. So we really don't talk about proteins. Yeah, okay. So proteins are kind of amines, amino acids. Yeah, I guess. But we always talk about secondary metabolites versus primary metabolites. But I guess it's fine. Wines and beers have amines. What amines are in wine or in in beers, because that's alcohol. And then if you remember, we talked about alcohol, and then we talked about that over time red wine can precipitate some acids, if you remember that. Yeah, so not, yeah. So in general, you see that amines, okay, codeine, that's good. So you see that amines are the things that kind of make you high, and they also kill pain, right? So that's why they are called narcotics, and that's why they are abused as well. Okay, so alcohol and maybe cannabis or cannabinoids, cannabis, they don't have amines in them, right? So those are the kind of two non-amine products that are abused, but pretty much everything else that you can think of, nicotine, for instance, these things are addictive, right? Nicotine, caffeine, codeine, you know, they're addictive. We also get in tea, actually. So tea has a lot of amines. Theobromine, for instance, is in tea. Theophylline, and theophylline is in small quantities. It's also then used for asthma. Okay, right. So alkaloids are stimulants. In other words, they get into the brain, and then they cause some effects in the brain, which effects could be a stimulation, right? So you feel good, you feel high. But they're also anesthetics, so they are used actually to suppress the feeling of pain. And maybe sometimes that's why they're actually abused, because you just don't want to feel the pain. They're used as antidepressants, so pretty much and as antipsychotic agents. So a lot of the stuff that we use for any brain, modifying brain function of one sort or another, whether it's depression, anxiety, psychosis, we generally, these things would generally be amines of one sort or another. So yeah, so here you go. This is caffeine, right? This is caffeine, stimulant. If you don't get your caffeine in the morning, it's also in chocolate. A bit of it is in tea, you know, and we put it in soft drinks. So Coca-Cola, for instance, Red Bull, right? Nicotine, yeah, you rightly pointed out, increases the adrenaline. Again, you remember epinephrine is adrenaline level in the blood, causes addiction to tobacco, and that's why people are not happy with the president right now, because yeah, these people are hooked and they can't get their fix. Okay, and so then we get heroin here, morphine, codeine. These are called narcotic agents. Okay, because narcosis, they are painkillers. Okay, and they've been used for centuries. It's just that now they are abused. But by far, still the most important painkillers that we have at our disposal are these guys, morphine derivatives. Okay, so morphine is at the center of it all. Why is morphine at the center of it all? It's because it's a natural product that comes from the poppy. Right now, where do poppies come from? I've just told you that cocaine comes from the coca plant, and the coca plant is mostly in South America, right? Right, Colombia, Mexico, and those areas, right? And the poppy, well, the poppy happens to be very popular in Afghanistan, right? So if you think about it, wherever Americans have gone and caused trouble, it's really because there's a drug involved, right? So the Americans were causing trouble in the 80s because they were trying to disrupt the narcotic trade. Some people say they were actually making lots of money from the narcotic trade. And then in the early 2000s, late 90s, early 2000s, they went into they went into Afghanistan, and because they were saying that the Taliban are using proceeds from the poppy plant to fund terrorism, right? But it's not the morphine that is important in this. It is heroin that is important, right? So morphine is a base. And now look at this beautiful chemistry. And I would like you guys to look at this, and I would like you to put in your chat box, how is heroin made from morphine? What's the chemical formula then? Okay, what is happening? What is the chemical reaction? Okay, can you please put it in the chat box? If you want, if you like, you can explain a little bit about what you see. Okay, chat box. Let me just open my chat box. Okay, yeah. Esterification, no, esterification, but where is that esterification, Arafat? And others, can you explain a little bit there? Okay, what's happening? Arafat, maybe you can unmute and explain.
So esterification happens at the hydroxyl group of morphine.
Okay, so you tell me what's the reaction exactly? So you've got morphine reacting with what?
With carboxylic acids.
Yeah, but what carboxylic acid is it?
Ethanoic acid.
With ethanoic acid. Yes. Okay. With ethanoic acid, what's the common name for ethanoic acid? Rapiri.
Acetic acid, sir.
Sorry?
Acetic acid.
Acetic acid, very good. Okay, so what you guys see, and maybe let me see if I can annotate a little bit here. So here you have an alcohol group, right? And what you do is, if you react the alcohol group with acetic acid, right? Otherwise known as ethanoic acid, this comes off, right? And then this comes on. So you end up with acetic acid in this region. The same thing you do here, okay? So actually heroin is also known as diacetyl morphine, isn't it? Because it is a morphine which has been acetylated. So the acetylation reaction there is a esterification reaction. Okay. When we go over here, now you guys tell me codeine. So codeine is, so let's get it straight. Morphine is a natural compound, right? This is a thing you get from the poppy plant, and then you acetylate it and you get heroin, right? Now, and heroin is highly addictive. Highly addictive. Okay. Now, if you modified it and you just wanted a painkiller, which is also addictive, by the way, but not as addictive as heroin, you get codeine, right? So you tell me, how do we produce codeine from morphine? So we start off with morphine. Now we want to produce codeine. What do we do there? Who's going to tell me? Chiviri. or Tembisile noma Swazi. Can you unmute and maybe tell me? There's also Chiviri. And Chiviri unmute? Are these people here, or maybe they just check in and then they just disappear? Teboheng, is Teboheng Moela there? Anyone?
Dehydration, sir.
Explain. You see, don't just say dehydration. Dehydration of what? You know, you should be confident of your answer,
alcohol.
even when you are wrong. Huh? Yeah. Explain to
Okay,
me.
sir.
Yeah. What's going on?
Okay, so we reduced alcohol, we dehydrated alcohol to make an ether.
Okay, so what could we use there for dehydrating the alcohol?
I think sulfuric acid.
Sulfuric
Yeah.
acid, yes. Okay,
Yes.
sulfuric acid. So in other words, what you need is you need methanol, right, in there,
Yes.
and then
Yes.
you need the morphine, and then you add in sulfuric acid. Okay, so you have a methyl
sir.
group floating around, which methyl group will then attach itself here. Okay, and what is this? What functional group does this become?
Methyl ether.
Yeah, it's an ether, right? So you can see here that what we have is on the one side a esterification where we have an ester, right? And then on the other side, ether formation, right? And this is that reaction that I showed you guys right at the beginning when we were talking about alcohol and its friends. So you can see that actually organic chemistry is very exciting because it's very simple things that can become very complex molecules. And in this case, you don't touch anything else. And remember, we're talking about amine. So if I give you this structure and I say to you, you know, what are the things that what are the functional groups that you see here? Annotate them. That's what we would use. The term we would use, you can tell me, you see ethers. There are two ethers here. What else do you see? No, sorry, there are two esters, right? And then what else do you see? There's an ether here. Do you see that? That's an ether bridge, right? And then you can tell me you've got an amine here, right? What have you got here? You've got a benzyl ring, a benzyl ring. But this is not a benzyl ring, my friends. What is this? This is just a cyclic ring, cycloalkyl, okay? Because it does not have these bonds. Do you see that? Yeah. So in other words, in terms of functional groups, we've got 1, 2, 3, 4, 5, 6 different types of functional groups, which you can then annotate and name. So if I say, you know, put a ring, hi dog, I'm in a lecture. Can I call you back? All right. Okay. Thanks. Bye. Yeah. Okay. So yeah, so when I say then put a ring and annotate, this is what I mean. So then here you can say benzyl. Okay, it's not going to write properly now, is it? But yeah, you can put benzyl. Okay, right.
So don't we also have a heterocyclic amine?
Yeah, so you could call it a heterocyclic amine if you like. That's really good. Yeah, but also you can also just point out to the amine. So if you say heterocyclic amine, you can see that it's this one here that forms a bridge, right? Yeah, you are completely right. Okay, now I just need to get rid of these guys. I'm not, let's see something. Clear all drawings. Okay, there you go. Actually, this is the first time I'm using this annotation, so that's pretty cool. Okay, so here we are then. Poppy. This is a poppy plant, right? And out of the poppy, we get morphine. Then from morphine, we can make an ether here. Okay. And yeah, so out of morphine, we get the morphine narcotics, codeine, heroin as well. Out of cocaine, remember the cocaine structure, and remember we said cocaine comes from the coca plant. Out of cocaine, we get these guys. They are also painkillers, but they're also mostly used as anesthetic agents. So procaine, lidocaine, lignocaine. Procaine, lidocaine, these are used mostly as local anesthetic. So if you go to the dentist, if before COVID, and the dentist will inject procaine, and so it does not go to your brain as such. Okay, so here we have the chemistry of cocaine, and if you remember again the structures, ester, okay, and it's modified. Okay, so they've done away with the ring. Okay, so this is a more radical. These are more radical kind of modifications. Okay, and we talk in terms of pharmacophore. So a pharmacophore is a group of functional groups, right, that give pharmacological effect. So it's not just one functional group, but a group. So if we took away the N here, this would cease being an anesthetic, okay? Because so for you to have anesthesia, you actually need this ester group here, right? And also the benzyl group, and then you need the nitrogen in here. So you can see over here the same here, the same here, the same. And so we call these again pharmacophores. Okay, so procaine is novocaine, and you guys know novocaine, right? There's actually a song about novocaine, novocaine. You know that song, right? So now you know. And what the guy in that song is trying to say is that I just want my pain to be numb, so I want novocaine, novocaine. Okay, right? And then you get meperidine. You can see that meperidine is kind of different, but it still has the functional groups that make it, that give it the pharmacophoric component. Okay, meperidine. There you go. Okay. We also have serotonin. So these are things again that are inside our bodies. So serotonin is a hormone. So when you're trying to control depression, for instance, you tend to want to preserve serotonin. Okay, and this is just showing you. Right. Do we have any questions there? Okay, so if no questions, maybe what we can do is we can try to reconvene tomorrow about the same time, and then we can look at amides. What I'm also going to do is I'm also going to send you, yeah, so I am going to send you a scenario that you can have a look at, so that we can try to merge what we've been doing over the past week or two and previously with some scenarios to get you some better grounding. Okay, there was a question. Someone put up their hand. Who was that? You can ask your question. Okay, do you want to do the amides now, or you want to do the amides like tomorrow? Because I had scheduled this to last until 3 o'clock. I think we still have some way and to go with the amides. Yeah, it's quite a bit to take in. So I think what we do is let's try and do it tomorrow. I'll send you a meeting request. Right. So a question from me is, do you guys want to try collaborate tomorrow, or you wanna come back to Zoom? Those that want collaborate, maybe put up your hands. Okay, but then, okay, with Zoom, I can record this, so I'll be able to send this out. Who's the class rep? Okay, right, Mabunda, Homolemo, do you want to ask or say something? Just unmute and say what you want to say.
I only wanted to say that I prefer Zoom.
You prefer Zoom,
Yes, sir.
but you've just used it. Is this your first time using Zoom?
No,
Do you use it for the other lectures as well?
no, for meetings
Sorry?
with Miss Carmen.
Sorry?
For meetings with Miss Carmen.
Oh, okay. So Collaborate is not working too well for you.
It does work well, but I struggle when I have to connect.
Oh, okay. No, that's fine. I think the other thing that you guys should check out is whether this thing is, how much data you use as well, so that we can, have a bit more, scientific. Okay. So, all right. So what we'll do is we can do Zoom then. I'll send you a link. And actually, there, you can also connect from Google Meet into Zoom. I just don't know how, but I'm not even sure if it's necessary. Okay, so we can do that. I've recorded this session. Can the class rep maybe send me, who's the class rep? Okay, the class rep is not here. Yeah, Kevin kind of said he had problems. I don't know about Cassandra, but yeah, Arafat, maybe send me your, I have your email address. Okay, let me see if I'll be able to load this thing Zoom onto my Twitter, and I'll also see if I can email it direct to you guys. I can't put it onto WhatsApp because it's too big. Okay. Oh yeah, so we can also try to do YouTube. Yeah, that's a great idea. Okay, I can load them onto YouTube. Yeah, and then I'll send you a channel. Okay, thanks, Arafat. That's very useful. Okay, so let's do that, and then yeah, I would really like to see. I'm going to explore some options in terms of how we can do some e-testing for you guys and see. Okay, but if you have any questions, you know how to reach me. Okay, Homolemo, you still got your hand up, or shall I put it down for you?
You can put it down, sir.
Okay, all right, cool. All right, so I think let's try and meet again tomorrow, even if it's for an hour. Okay, thank you, bye.